Welcome to my YouTube channel Physics and Mathematics classes. In this video, we are going to find the resultant force on any charge due to the other charges in a system of charges. When number of charges interacting with each other, each charge experiences a force, a resultant force due to the other charges that can be found out by using the principle of the superposition. So in this video we are going to derive the expression for the resultant force on any charge due to the system of the other charges. I am Jagdish Narayan, teaching physics and mathematics. Please watch my video till the end. Press the like button. If you are not subscribed yet, please subscribe my channel and press the bell button for the notifications of the new coming videos. So let's start the video. Principle of superposition. What is the principle of the superposition? Where we use the principle of the superposition? Consider a system of charges. Consider a system of charges. When number of charges are interacting with each other, then the number of charges together is called a system of charges. Let us consider Q1 charge is here, Q2 charge is here, and Q3 here, Q4 here. Consider a system of 4 charges. So Q2 charge exert a force on Q1 in this direction. Let us consider this is f of 1, 2 vector. Similarly, Q3 charge also exert force on Q1. The force is called F13. So Q3 exert force on the Q1. This is Q1 charge. Similarly, Q4 also exert force on the Q1. It is called F of 1, 4. So look at here. On Q1 charge, this is Q1 charge. Q2 exert force, Q3 exert force, Q4 exert force. So force between any 2 point charges we can find out by using the Coulomb's law. What is the force? F of 1, 2 vector is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. In vector form, R12 square into R12 cap. This is the force between 2 point charges. Let us say Q1 and Q2. You know that Q1 experiences force due to Q2. So at the same time Q2 also experience force due to Q1. But now here on Q1 due to the other charges there are 3 number of forces acting. F of 1, 3, F of 1, 2 and F of 1, 4. So how to find the resultant? Force acting on the Q1 due to the other charges. So this is what is called as the finding the resultant force on any charge due to the other by using the principle called principle of the superposition. So what the principle of the superposition states? The principle of the superposition states very simple statement. When number of charges are interacting, that is we go for the statement. of the principle of the superposition. So the principle of the superposition states that the principle of superposition states that when number of charges interacting with each other, the resultant force on any charge, please follow that, the resultant force on any charge is the vector sum of, this is very important because force is a vector quantity. Force on any charge is the vector sum of all forces acting on that charge charge acting on that charge due to the other charges, So this is the statement of the principle of the superposition. Please follow that. I repeat once again. What is the principle of the superposition states? The principle of the superposition states that, it's very simple. The principle of the superposition states that when number of charges, remember, when number of charges interacting, that is nothing but we considered a system of charges. When number of charges interacting, the resultant force on any charge is the vector sum of the all forces acting on that charge due to the other charges. So look at the diagram. On Q1 charge, Q2 exert force. On Q1 charge, Q2 exert force. Q3 also exert force. Q4 also exert force. Similarly, if we consider nth charge, let us say Qn, also exert a force on that. If you consider n number of charges, it will be is equal to f of 1 n vector. So now on Q1, so there are so many forces reacting. On Q1, there are so many forces reacting. So now we are going to find, by using the principle of the superposition, we are going to find the expression for resultant force on a charge due to the multiple charges. Let us go for the expression by using the same diagram. Expression for resultant force on a charge due to multiple charges due to multiple charges. So this is the expression you are going to derive using the Coulomb's law and also by using the principle of the superposition. Let us consider Q1, Q2, Q3, etc. Qn be the number of charges on the system of charges. Consider a system of n number of charges are there. So by Coulomb's law, remember, by Coulomb's law, what is that by Coulomb's law? The force on Q1 is, by Coulomb's law, the force on Q1 by Q2, the force on Q1 by Q2 is f of 1, 2 vector. So what is f of 1, 2 vector? That is f of 1, 2 vector is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R12 square into R12 cap. R12 cap is the unit vector drawn from 1 to 2. R12 is what? 1 to 2. So that is 2 to 1. So that is R12 is always equal to unit vector R12 is always equal to R21. R12 is always equal to R21. What is the R1 and R2? Where R12 is the distance between Q1 and Q2. So this is the expression for finding the force between Q1 and Q2. Similarly, we can find the force. Similarly, how to find that? Similarly, the force on Q1 by Q3 is F13 vector. So that is f of 13 vector equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R13 square Q1 Q3 divided by R13 square into R13 cap. So what is R13? R13 is the distance between is the distance between is this is the symbol of the between. Okay, Q1 and Q1 and Q3. Similarly, we can find out the force on Q1 due to the other number of the charges present in the system. Similarly, okay, okay, f of 1 4 vector, comma, f of 1 5 vector, etc. f of 1 n vector, okay, be the forces on Q1 due to Q4, Q5, etc. Qn respectively. So this is the way, okay, this is the way to find the number of forces acting on the Q1. So now how many number of the forces? There are n number of the forces acting on the Q1 charge due to the other number of the charges. That is, in case of n number of charges are there, n minus 1 number of charges exert force on the Q1. For example, if you consider the system of 10 number of charges, so on Q1 the remaining 9 number of charges exert force. So how to find the resultant? Remember, force is a vector quantity. Force is a vector quantity. We have to follow the vector algebra in order to find the resultant force on Q1 due to the other charges. So because of the reason, we use the principle of the superposition. So what the principle of the superposition says? By the principle of the superposition, by the principle of superposition, what the principle of the superposition says? By the principle of the superposition, the net force on Q1, let us consider this is F vector. The net force on Q1, that is called F vector, is equal to vector sum of, vector sum means we have to take the vector addition of the number of vectors by using the vector algebra, either by using the triangle of the vector addition or parallelogram of law of vector addition. So using that we can find out the resultant force, that is f of 1 2 vector plus f of 1 3 vector plus f of 1 4 vector and so on. So up to how many number of charges interacting we have to consider. So we know that F vector is equal to, what is that? 1 by 4 pi epsilon naught is common in all the forces acting on the Q1. What remains? Q1, Q2 in the first case divided by R12 into, okay, Q1, Q2, the first case R12 into R12 cap plus Q1, Q3 divided by Q1, Q3 divided by R13 square, this is square, sorry, square, R13 cap and so on. So we have to consider the last force, that is Q1, Qn divided by R1n square into R1n cap. So now by using the principle we can find out this is the resultant force acting on the Q1 charges. So by using the summation symbol we can simply write down, so 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught sigma times, let us consider this is Q1, Q1 is common in all the cases, take outside, okay, put Qi, ith charge, where I is equal to 2 to n, where I is equal to 2 to n divided by R1I square. What is I? I is the ith charge. R1I is the distance between Q1 and ith charge, Qi, into R1I cap. R1I cap. This is the resultant force. This is the expression for the resultant force by using the principle of the superposition. By using the principle of the superposition. So how to find the resultant force? By using the vector algebra we can find out easily. This is the expression for resultant force acting on the charge, on any charge due to the other charges in the system of charges. So very simple derivation. So please follow the principle of the superposition because we have to find the resultant force.